So now for the interest, it's going to be based on the beginning balance. So we take the beginning balance, we multiply that by the interest rate. So we have that set up for here. Interest rate, we have to reference that cell with F1s. Multiply that by the interest rate. So we have the interest for the time period. We can fill the additions and the interest formula right. For the opening balance, it's going to be a corkscrew calculation, where the opening balance for this time period is going to be the closing of the prior period. So in order to model going forward the principal repayment on new lease liabilities, it's going to be based on a similar formula we did for the finance leases for the right of use of assets for the depreciation. So essentially we are just saying that we're going to be depreciating the assets the way we depreciated the finance lease and right of use of assets for 10 years. We're going to be repaying the new leases based on a similar formula to that. So in order to do that, we will take, as we did before, we take the negative of the net additions, reference to F 2 times, and divide that by, in our control panel here, the lease term for new leases of 10 years. The references are with F1s. We can copy that and paste here as. We keep pasting here, normally using effort to repeat the last action. So we have that setup in place. So having done that, going forward, it's going to be a pretty different formula where we'll be using a combination of two different time periods, vertically and horizontally, to determine the remaining amount that needs to be paid for each time period. So in order to do that, we're going to set this, since it's a waterfall, it's going to be pretty easy. So we're going to set this to be equal to if we go to the time period we set up here, reference us with F or 2 times. If that time period is greater than this time period here in B215, which we reference with F4 3 times because we have to copy that formula across, plus the lease term for new leases, reference us with F1s, minus 1, then we want that cell to read 0 because there is nothing left to be paid. So if the time period plus, which is I-139 in the year 2022, if that time period is greater than the time period we are in, plus 10 years minus 1, since we're already accounting for the first year of repayment already, then we want that cell to read 0 because everything has already been paid off. Otherwise, whatever is left to be paid, we want it to read whatever is left to be paid, which is the remaining principal repayments that needs to be paid. And in this case, since it is equally amortized, we just set it to be equal to whatever is left, which is right there. We can close the bracket and we press enter. So that's the same thing we did for the depreciation formula. We can just fill this right with Control R since we already anchored everything. As you can see, everything gets paid off by the year 2030, and before the year 2031, everything is paid off. So this is an equal amortization of principal. So this is a secure debt, as we can see. Even for the existing leases, we can see that it is equally amortized the principal, and we can see here how equally amortized the principal is because we are divided by the weighted average lease term for the existing leases, and we can see here that everything gets paid off by the end of the year 2027. Just as we did here as well, here everything is equally amortized, and we can see that by the end of 2031 everything gets paid off. So since we have done that already, and we can easily just copy this for all other capital expenditures that needs to be paid. So we can just copy and paste here since everything is anchored. We can just copy and keep pasting. Make sure that we're copying everything from here. Just copy and paste. Use F4 to repeat the last action. As you can see, we have that set up there.